Hello, this is Mr. McLaughlin, and welcome to your first e-learning assignment. We are covering Chapter 11, called Data Analysis and Statistics, and our first lesson is 11.1, Finding Measures of Central Tendencies. Before we begin that, though, let's try some more of those lovely SAT practice problems. I picked out 4 good ones here off of last year's exam, and please hit the pause button and try all 4. And then come on back and check your answers. Welcome back. In the first problem, hopefully you read through it very clearly, and of course, check out your answers here, guys. Check out your answers there. They all are set equal to P. So the easiest way, and hopefully the most practical way, to solve that problem would be just to use good old cross multiplication. So if we cross multiply right away, we would take the 6 and multiply it by the e and have 6e on one side of the problem. And we cross multiply, of course, with the 1 and get the o plus the 4m plus the p on the left side of the problem. And if we wanted to get the p all by itself, we would just subtract out the o and the 4m. So I'm getting P equals a 6E, subtract out the O there, and subtract out the 4M, and that should get you lined up with answer A. If we move to the upper right-hand corner, the problem about the triangle and the angle measurements, you might notice this great given information. Right away, it's telling you that 2 side lengths are equal to each other. So that is our classic isosceles triangle. You put a nice slash mark through RT and TU, and then remember, if 2 sides are equal, then their base angles are also equal. So the first thing that I did on this problem was find out what the measurement of angle R and angle U happen to be. And we do that by just taking 180 degrees and subtracting the 114 from it. And if you did that, you'd get 66 degrees. Now that's split over 2 angle measurements there for both R and U, so you divide that by 2, and we get 33 degrees. So 33 degrees going for angle U, and of course also coming all the way over here for angle R. So I'm just going to kind of slip that right there and put down 33 degrees. Now, connecting the rest of the triangle to find out what angle X is, and I'll try to throw a different color up here, but we're trying to find out what's going on right there. So it's the old classic, use angle measurements from the other triangle to get there. Well, first thing would be this 114 now. That 114 is supplementary on the other side of the 114. And if you do that, you're going to also get 66 degrees. Kind of crazy there. We got 66 degrees all over the place. And now by the 3 angles of the triangle theorem, the 66 to 31 would leave this guy here to be 83 degrees. And then we would build on our vertical angle theorem, which would put this 80 angle here is of course equal to that angle there. That's the vertical angles. And then to find out what good old angle V is, we could say angle V plus the 33 degrees plus the 83 degrees has to make the 180. And hopefully, of course, the math should be pretty easy there. C would be our answer. X should be equal to 64. And again, I'm calling this angle V here, which in our problem actually represents X degrees. So X degrees should be 64. If you have any questions on any of the problems, feel free to send me an email. I would definitely get to you as soon as possible. All right, bottom left-hand corner. First thing I did here is I just draw myself a rectangle. A nice rectangle picture. And of course, in this rectangle, it simply says that the width of the rectangle is going to be W, and that the length of the rectangle is going to be 6 feet longer than the width. So that would be W plus 6. And we all hopefully know, in the land of rectangles, opposite side lengths are equal to each other. If we add up all the side lengths, which of course this question is asking you for the perimeter, which the following expressions would represent the perimeter of this rectangle. W plus W plus W plus W will get you 4W. And of course, the 6 plus the 6 will get you 12. So that answer should give you B, 4W plus 12. Last one here would be a lovely connection going back to first semester working with radical equations. So big thing in this one is you got to get the radical sign all by itself. So first thing I did was I subtract out 4 from both sides. The square root of 2x plus 6 is now going to be equal to x minus 1. This radical equation has now had the radical sign isolated. If you remember, once you get that radical sign isolated, you would square both sides to get this equation to become radical free. Square root symbol gets canceled out by squared sign. We got 2x plus 6 on the left-hand side. X minus 1 times x minus 1 would come from the quantity of x minus 1 being squared. And right away now, we're jumping into a quadratic equation. X squared minus 2x plus 1. At this point, we would set this quadratic equation equal to 0. And once we set equal to 0, we should be able to solve it pretty easily by using some nice factoring. So I'm going to subtract 2x and subtract 6 from each side of this equation. And in doing so, I'll get my left-hand side to be equal to 0. And now I'm staring at x squared minus 4x minus a 5. This would now go back to our mathing technique that we spent a lot of time in the first semester. And hopefully everyone that's good at mathing, x times x gives you x squared, negative 5, and positive 1 would be our factors there. And then remember our use of the zero product property. Once we get them set equal to 0, the number that makes each of the binomials turn into 0 are always the opposite sign, so positive 5 and negative 1, and that would give us example, hopefully matched up there with letter C. All right, so there's a nice little SAT review, and we are going to now jump right into some good measures of central tendency. To continue to record, okay, because I can't move the page over, you know. Select no, and then can you move this? There you go. Oh, is it recording all this right now? No. Can it stop? Okay, but when you hit... Well, we had a little glitch there, but we're back going. I'm trying to make sure we get this wonderful file in a nice order for you. All right, we're going to start with some nice, easy definitions. These go back to kind of like pre-algebra, Algebra 1 days. I'm sure most of you guys could rip through these definitions without much help, but biggest one, of course, would be starting off at the top here. The mean represents the average of the set of numbers. The median is always looking for your middle term, your middle value. The mode is the one that is most popular. And the range has a nice little formula for it, which you guys could think about with the temperature outside. What's the high temperature? What's the low temperature? What's the difference between them would represent the range, and that's, of course, max minus min. We got some nice, straightforward problems here for you. I'll let you guys take a look at that for a second. So we're looking at two different offices here, Office A and Office B. And what we want to really kind of think about is Office A is having one scenario going on, and then Office B is having another scenario going on. And that scenario is just taking a look at how long you have to wait before you actually get to see the veterinarian.
Yeah.
All right, so in Office A, if we want to find the mean, we must average out all of the wait time. So first of all, if you think about it, there's 9 different wait times here. Check them all out, 14, 17, 18, 19, 20, 24, 24, 30, and 32. Hate to be that person who had to wait 32 minutes to see the veterinarian. But if we want to find what the mean is, remember what mean is. You got to take the sum of all the wait times, and you must divide it by the number of wait times. So here we had 9 people waiting to see the veterinarian. The total sum that they waited was 198 minutes. 9 people did that, so that average would be 22 minutes for our wait time. If we now go over to Office B for question B, and it says, what's the meeting wait time in the office? Well, if you look at it, they are in order. 8, 11, 12, 16, 18, 18, 18, 20, 23 are already put in order. And it's nice when they're put in order. And of course, the order is from smallest to largest. So in this particular office, we want to find the median. We again have 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. There are 9 values in here. And of course, we find the one that's in the middle. That would be the old number 18. So here, our median is the middle digit, and the middle digit is 18. And then finally, ask for the mode, but not just of one of the offices, of both of the offices. So by far, if you start to look, we got 18, 18, 18 3 times in Office B, and we also got 18 over here in Office A. So by far, the mode, it happens 4 times, guys. And of course, that 4 times would be the most popular. And that one, again, is 18 minutes. And now if you could just flip over the page, we'll go to our question about the length of fish. So the table lists all the lengths of the fish that were caught, and we had a random sample of 21 brown bullhead fish that were caught. You can hear. And there it goes. Sorry about that. We're trying to iron out the glitches as always. But check out this table here, guys. Big table talking about 21 brown bullhead fish. And the first thing I want you to do, again, is just find the median. Find the mean here. We want to find the mean of this set of data. And again, if we want to find the mean, it's always going to be the sum divided by the total number of objects or elements that are in your sample space. So once again, we have 21 fish here. So if you find your sum here, I got that to be 262. Add up all the digits in the table, and then we're going to divide that by the 21. So the average length of a fish would be about 12.48. Again, 262 divided by 21. The mean, of course, is going to be the middle again, going for the median here, the middle value. So if you count the 21 fish, we'd like to say, hopefully, item number 11 would be in the middle there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cha-ching, there would be 11. That would be in the middle. So the median here is, again, 12. Range should be the easiest one of ever. Range is always going to be coming from your max minus your min. So the biggest fish that we caught was 24 inches. Smallest guy that we caught was only 8 inches. And that 24 minus that 8 should give us 16. Nice, easy questions revolving around the great brown bullhead fish. Down here in question E, it's a little bit of a analysis question. And the analysis is going with what changes the most if you happen to take that big fish, that 24-inch fish, out of the data here. So by far, if you think about it, that's got to go with the range. You know, originally the range up here was that 24 minus that 8, which was 16. If we take that fish out and we say, okay, well, 24 up here on top is being removed from our data. So now our range is going to have a maximum size fish of 16 inches. So now we'd say the range is 16 minus the 8, which is going to be the 8. And that would be the biggest change for sure. So of the mean, mean, and range, which changes the most if you remove the 24-inch fish? And that would be the range. The range value would change the most. All right, last example here for our first E lesson of this Chapter 11. This time we're talking about the months and making a comparison of what the high temperature of every month was in the first column of numerical data. And then in your second column of numerical data, you're looking at the amount of precipitation, which again, amount of rain, amount of water, maybe amount of snow that fell for each one of our months. So question A again is, what is the mean? What's the average monthly high temperature? Again, the mean for the monthly high temperatures. So in this set of data, again, you must add up all the elements in the first numerical column. If you add all those digits up, you're going to come up with 663. Again, there's 12 months in the year, so our average monthly high from our set of data would be about 55.25 degrees. Question B asks, what's the median of the average monthly precipitation? So for this one, you have to put them in order and find your two numbers that are in the middle. So when I put them in order, 2.43 and 2.66, we're going to be in the middle. Remember, you have to order these from smallest to largest when you want to find the median, the number that's in the middle. And since we've got 12 months, we have two digits in the middle. So we're going to average those two numbers together, 2.43 and 2.66. And if we divide that by 2, this would give us our average monthly precipitation for the median of that data, which would be about 2.545 if you carried out the 3 decimal places. And question C now is talking about the range of the average monthly precipitation. So the most rain that we ever happen to get in our second numerical data column was 4.30. That happened there in August. There's the most rain we got. And the smallest amount of precipitation back there in February, about 0.81. So remember, it's range here, guys. So it's max 4.30, subtract the min 0.81. That range would be 3.49. And then finally, the last question here for you. Do either sets of data, whether we're talking about the high temperature or the precipitation, do either of them have a mode? Again, mode's the most popular, so if you scan through them, first of all, there's no mode here. None of those guys are repeated values. There's nothing there in common with any of those digits. But for sure, I believe if we look at the month of April, high temperature of 58. October, also high temperature of 58. We definitely have a mode. Do either sets have a mode? Yes. Which one? Average high temperature does. And that would happen to, of course, be 58 degrees that occurred twice, once in April and once in October. Hopefully that was a good lesson for you and a nice review of all the measures of central tendency going back to probably 6th, 7th, 8th grade, your mean, median, mode, and your range values. We now, of course, will attach a worksheet here for you to work on. It should be right there in your packet, the homework from section 11.1. It's page 747, 9 through 21 odds, 27 and 30. And if you scroll over one more page, you'll see your homework. If you could take a picture of that and then send it back to me, that would count for your assignment for our first e-learning activity. All right, hope everyone's staying safe and healthy. And this is Mr. McLaughlin signing off.